Hey everyone, welcome to Math 104, Section 1.7, Part 1, Absolute Value Equations. Please take a look at the introduction. When planning an ocean voyage, an explorer would like to know how far it is to the destination as the crow flies, which is just in a straight line. Starting point is Victoria Island, the largest island in the Arctic Ocean. The destination is an uncharted island believed to be directly west of Victoria near Greenland. The GPS coordinates are given, and the explorer believes that the uncharted island is at 8 degrees north and 12 degrees west. How far is this proposed voyage? Well, this is one question we're going to learn how to answer today. In order to do so, we need to look at the idea of distance. And in order to calculate distance, we need absolute value. So a little review of the absolute value. Definition of absolute value, you can think of it in an informal way as being the distance from 0 on the number line. So 3 is 3 spots away from 0, so that has an absolute value of 3. In the other direction, negative 3 is also 3 units away from 0. So the absolute value of negative 3 is 3. So the absolute value function turns anything positive. Any number is going to be a positive number coming out of the absolute value function. Now, a more formal definition is if x is greater than or equal to 0, then the absolute value of x is just itself. So nothing changes there if it's 0 or greater. But if x is negative, then we have to switch the sign. So the absolute value of x would be the negative of x. So for example, if we're talking about x is negative 10, we'd switch the sign to positive 10. Absolute value of negative 10 is positive 10. So for example, here we got absolute value of 7. That does not change the sign because it's already positive. This isn't like inverses where you switch the sign in all cases. So if it's positive, it stays positive. But here we got a negative value inside. So let's use this definition. If x is less than 0, it is less than 0, then the absolute value of x is the negative of whatever's inside here. So that would be written like this, negative of negative 8, which is 8. Now, generally, we don't write that step. We just go right from here to here, though. But that shows you why we get 8 out of it. So in finding distances, we're going to use absolute value. The absolute value of the difference between coordinates. Difference is subtraction. So that means if we wanted to find the distance between 2 points, we're going to subtract the coordinates and then take the absolute value. So for example, we've got 2 coordinates here. We've got x at 154 and x at 232. And we want to find the distance between those 2 points. So I'm going to take the absolute value of the difference. So I'm going to do 232 minus 154. Now order of operations is going to work inside the grouping symbol first and subtract these. So we get 78, and the absolute value of 78 is positive 78. Let's see what happens when we reverse the coordinates. All right, now we're going to do this the other way. 154 minus 232, that gives us negative 78. Absolute value of negative 78 is positive 78. So it doesn't matter which way you subtract the coordinates, because if you get a negative, the absolute value just removes the negative. And so we get a positive value, which makes sense because distances are always positive. And that brings us to your turn number 1. Find the distance between x equals 27 and x equals negative 34. So we can subtract this way, 27 minus negative 34. Subtracting the negatives is like adding, so we'll convert that to addition, 27 plus 34, and we get 61. Absolute value of 61 is 61. So we are going to be solving equations involving absolute value. Now let's take a look at this. Let's say we know the absolute value of x equals 3. Can you find 2 points on the number line that you can plug in for x to get 3? Sure, we got 3. We plug that in for x, the absolute value of 3 is 3, or negative 3. Absolute value of negative 3 is 3. So for most absolute value equations, we're going to get 2 answers. And we'll see why that happens. Now, if you want to find the solution by graphing, we can graph the 2 sides of the equation and then find the points of intersection. All right, so if y equals 2, that graph looks like a vertical line across, and the absolute value function looks like this. It means we got 2 points of intersection. And here's another reason why we get 2 solutions out of the absolute value equation. So here we got negative 2 and 2. So the solution to this would be x equals negative 2 and 2. So we have a strategy for solving absolute value equations. First of all, isolate the absolute value. We have to get it by itself on one side of the equation. If there's anything else attached to it, this method will not work. Then we split the absolute value equation into 2 equations, removing the absolute value. All right, so this equation here, absolute value of x equals 2. We have the absolute value part isolated on one side of the equation. It's all by itself here. So here's where we split this up into 2 different equations. The first equation is this equation, just remove the absolute value bars. So x equals 2. Don't change anything. The other side, you take the inverse of the other side of the equation, the inverse of 2, which is negative 2. So there's our 2 solutions, 2 and negative 2. And at this point, these equations are already solved, so we're done. There's our 2 solutions. Your turn, number 2, solve those 3. Some of these are a little tricky. So for the first one, we're going to split this up into 2 equations since we have the absolute value isolated. First one, just remove the absolute value bars and write it exactly as it is. And the second one, set it equal to the opposite on the right-hand side, x equals negative 7. So we have 7 and negative 7 for that one. Now for this one, we need to find a number that if we plug it in here, we get a negative 7. No such number exists because absolute values are always positive. So no solution. Now this one is, especially after doing this one, is a little tricky. A lot of people look at that one and say, oh, there's no solution to that one either. Well, as it turns out, that's not the case. Let's use this procedure on this one. So first thing we do is just, when we split this thing up, just remove the absolute value bars. So negative x equals 7. And then on the other side, we said what's ever inside the absolute value bars equal to the opposite of the other side. So negative x equals 7, negative x equals negative 7. And then we'll divide both sides by negative 1, and we get x equals negative 7 over here, and x equals 7 over here. So you actually end up getting the same answers as you do over here. That negative ends up being irrelevant. So make sure you can differentiate between this situation and this one. Absolute values can never equal a negative number, but you can have negatives inside the absolute value bar. All right, next up, we're going to look at one that requires a little bit of work after we split it up. So the next example is the absolute value of 2x minus 3 equals 5. Yeah. So we have an absolute value that is isolated. It's all by itself on one side of the equation. So now we can split up. Make sure you do not split up until you have something that looks like that. Okay, now remove the absolute value bars and write the equation exactly as it is. Just 2x minus 3 equals 5. And then the other side, 2x minus 3 equals the opposite of this side, negative 5. And those are the two equations that we need to solve. So we'll solve them individually. Plus 3, 2x equals 8, divided by 2 on both sides, and x equals 4. And on this side, 2x equals negative 2, divided by 2, and x equals negative 1. Now we've got our two solutions. Possibly. We should check. I'm going to take this 4 and plug it in for x. 2 times 4 is 8, minus 3 is 5. Absolute value of 5 is 5. So that works. I'm going to plug in negative 1. 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. Absolute value of negative 5 is 5. So both of these solutions check. Your turn, number 3. Absolute value of 3x plus 4 equals 19. We have the absolute value isolated, so we can split it up. All right, remove the absolute value bars. 3x plus 4 equals 19. Make sure on the step where you split it up, you remove the absolute value bars. That's something I see a lot of students do. They'll just leave the absolute value bars in there and then start making mistakes. So remove those absolute value bars. All right, so we've got the equation as it is, and then over here we'll set it equal to the opposite on the right-hand side, so negative 19. We'll solve each of these. So we got 3x equals negative 23, and that gives us x equals negative 23 thirds. So our two solutions are 5 and negative 23 thirds. All right, let's plug these in to check. We got 3 times 5 is 15, plus 4 is 19, absolute value of 19 is 19. That checks. Negative 23 thirds, when we plug it in here and we multiply, those 3's are going to cancel. So we get negative 23. Negative 23 plus 4 is negative 19. Absolute value of negative 19 is positive 19. So those two check. Now, next example. We got 3x minus 7 plus 4 equals 6. And all the examples we've seen so far, the absolute value has already been by itself on one side of the equation. But here, this is not the case. Big mistake I see with students solving these is trying to split it up from here. That will not work. Don't do that. You have to get it, the absolute value all by itself on one side of the equation. It means we need to get rid of this 4, so let's subtract 4 from each side. So absolute value of 3x minus 7 equals 2. And now that we have the absolute value by itself, now we can split it up. 3x minus 7 equals 2, and 3x minus 7 equals the opposite, or negative 2. Don't make this side negative. That's another mistake I see. Just make sure the opposite side is what you turn negative. Okay, solving these. Plus 7, we get 3x equals 9, divided by 3, and x equals 3. And on this side, plus 7, 3x equals 5, divided by 3, and x equals 5/3. And as usual, make sure you plug them in and check. Your turn, number 4. Just a reminder, I don't stop during these, so if you're working on these, just pause the video and restart when you're done. All right, we have to get the absolute value by itself. We cannot operate with this 4 there. So let's get rid of the 4 by adding, or get rid of the negative 4 by adding 4 to both sides. So that gives us absolute value of 5x plus 6 is 19. And now that the absolute value is by itself, now we can split it up into 2 equations. All right, first equation, remove the absolute value bars. And on the other side, 5x plus 6 equals the opposite, which is negative 19. Solving these, we get x equals 13/5 and x equals negative 5. Looks like I put the wrong sign in here. Yeah, this should be 5x minus 6. I switched it to positive. I'm going to fix that real quick. It's going to change the sign on the 2 answers. Plus. I'll make this negative 13 here. And over here, this will be positive 25. So it switches the signs there. Okay, 5 and negative 13/5. Next example. There may be things that are right next to the absolute value bars. We multiplied by whatever is inside the absolute value. So you got a 2 coefficient outside the absolute value bar. All right, let's get rid of this first. Negative 5, negative 5. Got to get that absolute value completely by itself. So that gives us 2 times the absolute value of x plus 1 equals 10. Now we need to get rid of that 2. So we'll divide both sides of the equation by 2. These will cancel, leaving just the absolute value of x plus 1 equals 5. All right, now we've got the absolute value completely alone on one side of the equation. So at this point, we can split it up into 2 equations. Solving. We get 4 and negative 6. Your turn, number 5. All right, we need to get this by itself, so we need to remove those two things. Let's get rid of the plus 5 first. All right, now I'll divide both sides of the equation by 3 to get rid of that coefficient. All right, now we've got the absolute value isolated. At this point, we can split it up into 2 equations. Remove the absolute value bars to get x minus 3 equals 5. And then set it equal to the opposite in the other equation, x minus 3 equals negative 5. Solve both of these. And we get x equals 8. And x equals negative 2. Now, absolute value equations can have different numbers of solutions. So let's look at 3 different situations here. First equation, we've got absolute value of 2x minus 1 equals 6. Two x minus 1 equals 0. Absolute value of 2x minus 1 equals negative 2. Okay, so here's our 3 different situations. If you have an absolute value and it's by itself, this only works when it's by itself. If you have things attached to it, you're going to have to get it by itself before taking a look at this. Okay, so if you have an absolute value equal to a positive non-zero number, you get 2 solutions. If you have an absolute value equal to 0, 1 solution. And if you have an absolute value equal to a negative number, absolute values can never be negative, so no solution to that one. So there's your 3 different scenarios. And in a moment, we'll see exactly why you only get 1 solution to those. All right, so next example, we're going to solve this one. We have to get this absolute value by itself, so let's get rid of the 13 first. Then we'll divide by 4. All right, now we've got the absolute value by itself. And now it's set equal to a negative number, so there's no solution. Now if we had tried to do this analysis at the beginning, see it's equal to 5, it's supposed to give us 2 solutions, but we haven't isolated it first. So you have to isolate it or it's going to give you an incorrect impression of how many solutions. Your turn, number 6. So isolating the absolute value, subtract 14 from each side, and then divide by 3, we get absolute value of 4x minus 7 equals negative 2. No solution. Now we're going to solve 4 times the absolute value of 3x minus 15 equals 0. Now let's get this thing by itself. Divide both sides by 4. Now we've got it by itself, so now we can split up into 2 equations. So we got 3x minus 15 equals 0, and 3x minus 15 equals the opposite of 0, which is negative 0. But negative 0 is just 0. So really, these are the same equations, so we don't need to solve both of them. We just need to solve this one. That gives us x equals 5. And if you think about it, this makes sense because when we were looking, let's say we had something, absolute value of something equals 4. We're talking about points that are 4 units away from 0 on the number line. So we could go this way, 4 units, or we could go to the left, 4 units. But in this case, the absolute value equals 0. So we're talking about all the points that are 0 away from 0 on the number line. Well, there's only one point that's 0 away from 0, and that's 0. So that's why there's only one solution. Your turn, number 7. All right, divide both sides by 3, you get absolute value of 4x plus 12 equals 0. Remove the absolute value bars. And solve. All right, subtract 12 from both sides, we get 4x equals negative 12 divided by 4 on both sides, and x equals negative 3. All right, next up we're going to look at equations that have more than one set of absolute value bars. All right, now we're going to do what we did before. Is since we have an absolute value here that's isolated, what we're going to do is split it up into 2 equations, just like we do with regular ones, except with an important difference. So the first one, just like before, we just remove the absolute value bars. So 4x minus 1 equals 3x plus 5. So there's one equation we need to solve. And the other equation then we're going to do 4x minus 1 equals, now we want the opposite of the entire right-hand side. So that means we have to put a negative and then put the right-hand side in parentheses, just like that. Now we've got the opposite of the whole thing. Make sure you put in parentheses because we need to distribute that negative into here. All right, let's solve this one first. All right, going to subtract 3x on both sides and add 1 to both sides. So that gets rid of this. So we got x equals 6. Now on this side, we're going to start by distributing the negative into the parentheses. So we got a 4x minus 1 equals negative 3x minus 5. Make sure you apply the negative to both terms. And we can solve from here. So I'm going to add 3x to both sides and add 1 to both sides. So that gives us 7x equals negative 4 divided by 7, and we get x equals negative 4/7. So there's our two solutions. Your turn, number 8. Absolute value of 3x minus 4 equals absolute value of 5x plus 12. All right, let's break this up into two equations. We got 3x minus 4 equals 5x plus 12. And on the other side, we got 3x minus 4 equals the opposite of 5x plus 12. Let's solve this one first. I'm going to subtract 3x from both sides. I'll bring the x's over here, so I'm going to subtract 12 from both sides. So we get negative 16 equals 2x divided by 2, and x equals negative 8. Now in this equation, we're going to take that negative and distribute it in. So we got 3x minus 4 equals negative 5x minus 12. Alright, now let's combine like terms. Add 5x to both sides. And add 4 to both sides. So that gives us 8x equals negative 8. X equals negative 1. All right, to finish things off, we'll go back to the introduction and find the distance between Victoria Island and the uncharted island that the explorer is trying to find. All right, the prime meridian, darken that up. It's a line connecting north and south poles that runs directly through Greenwich, England. And that's where Greenwich Mean Time comes from. You've heard of that. All right, so there is our prime meridian. And so we measure from the prime meridian That's basically the starting point for measuring longitude. All right, so we got our 2 points here. We got Victoria Island, and here's the equator. Try to draw that on here. Sorry about my artistic skills. I'm pretty incompetent at drawing. Okay, 80 degrees north, and then east is to the east of the prime meridian. So we got 80 degrees north, which is somewhere up here, and 37 degrees east. So we're going to be off to the right of the prime meridian there. And we want to go 8 degrees north and 12 degrees west. So west is going to be left of the prime meridian. So there's approximately where we're going. Starting here, Victoria Island, and end up over here at the uncharted. All right, now we know that the values west of the prime meridian are given negative values. The island is 12 degrees west, so we're just going to call this one negative 12 degrees. And this one is to the right of the prime meridian, so this stays positive. So this one is positive 37 degrees. So now let's find the distance between those 2 points in degrees. So the distance is 37 minus negative 12, absolute value. So that's the same as 37 plus 12, so that is 49 degrees is the distance between those 2 points. But that's in degrees, and we want miles. So we're going to have to do some trigonometry. Now that's not part of the class, so you won't be responsible for this. This is, in case you're going on to take trigonometry, this will be a good intro. Now, the length of 1 degree longitude in miles depends on the distance from the equator. Longitude, difference in longitude is the distance between these, like the lines coming down. If you have a couple lines representing 1 degree, well, there's going to be a lot bigger distance here on the equator because we have farther to go. But up here, we have much shorter distance to go. That means 1 degree corresponds with a lot fewer miles as you get closer to the poles. But at the equator, 1 degree of longitude difference equals 69.172 miles. But that's at the equator. And here's where the trig comes in. We can use the cosine function to reduce this as we go towards the pole. All right, if we were all the way up here at 90 degrees, cosine of 90 is 0. It means we'd be going every degree is worth 0 here. All right, so that means we need to know how far north we are, and we're given that we are at 80 degrees north. So 1 degree longitude at 80 degrees north equals cosine of 80 degrees times 69.172. So by multiplying by the cosine of latitude, it's going to reduce this down to 12 miles. So 1 degree of longitude up here is only 12 miles because we're so far north. All right, now we take that 12 miles and we're going to multiply it by 49 degrees. So we have 49 degrees of difference, and each degree is worth 12 miles. So the distance is 49 times 12, or 588 miles. So there's an application of using absolute values, distances. That's all that you'll be responsible for, is the absolute value and distance calculations. And then a little bit of trig as a preview what's to come if you're going to go on with the algebra path, take college algebra and trigonometry. Now this is a really important topic. Make sure you master this before the next course, or before the next class period, because we are now going to be studying absolute value inequalities, and we're going to be using everything we learned today.